This talk will be predominantly done within this window here. I might switch over to a browser every so often to kind of see some stuff on NPM and stuff like that. But for the most part, I'll just be working from here. I have, for those of you with laptops that want to follow along, there are written details of what I'm going to be going through available on GitHub at that repository. Yep, that's correct. And you can also, if you have Docker or Jupyter installed, you can follow along in a Jupyter notebook. So I'm not going to go into details of really what TypeScript is here. I'm going to start on a base assumption that people at least have an idea of what it's trying to do. But to give me like a little bit more of an idea, raise your hands if you already write TypeScript. You know what TypeScript is. Cool. Raise your hands if you're here because you want to learn how to write TypeScript and you start to explore. Great. That's basically half of one, half the other. That's awesome. Raise your hand if you have written an NPM module before. Any of you use TypeScript for that? I'm guessing not. OK, 1.5 people. Great. So yeah, so I'm basically going to be going into details into how to do that. So a couple of things to know before I get started. I'm just going to mention. So TypeScript is a language that compiles to JavaScript, which means that you can use it to create NPM packages. One thing that you don't really typically get when you install NPM packages if you're writing a TypeScript project is type definitions for those packages. You either have to install types externally, write them yourself, but sometimes you're lucky and they get packaged. And the entire purpose, really, of this talk is to show you how to package your type definitions along with the JavaScript code that you export from TypeScript in a way that allows anyone that's using your library to immediately be able to use those types. All right, so I'm going to jump straight into it. So the first important thing to do with any new project, any new package, is to start using some sort of source control. You will regret it later on if you don't have that. So first thing I'm going to do in this folder here is do git init, which will create a new repository in this folder here. And if we can do git status, we can see that there are no commits yet. And I've created a small README. So I'm just going to go ahead, git add, git commit. And there you go. We're ready to get going. The next most important thing when you're creating any JavaScript project is to have a package.json file. This is even more important and definitely required when you're actually writing an NPM module, when you want people to actually use those libraries. You can do this pretty easily with NPM init like that, but I'm actually just going to write it from scratch so we have the minimum possible amount of stuff in our package file as possible. So I'm just going to go ahead and create a new file. Can everyone see what's on the screen OK, by the way? It's big enough? Great. So we've got a new package.json. First thing we need is a name. How many people in this room are familiar with namespaces on NPM? Yeah, 2 or 3 people. OK. So NPM has a global namespace where you can basically upload a package with just some, say, for example, when you're installing Lodash or Express or something like that, you're just installing something from the global namespace. But you also have each user and each organization on NPM has its own namespace within which it can have whatever packages they like, and it's entirely controlled by that organization or user. So I'm actually going to publish an NPM module live as long as the internet holds up. during this talk. So I don't really want to clutter up the global namespace with a package that doesn't really do anything. So I'm going to use my own personal namespace for this. So, and that is all included in the name. So I'm going to do, that's what I'm going to call the package. So the name is one thing, and the other only required field that you need to have is a version. And how many people in this room are familiar with semantic versioning? Great, that's awesome. So the basic idea is you want to version your packages in a way so that it deals with backwards incompatible and backwards compatible changes, security hotfixes, that sort of thing. If you have a version that starts with 0, it's considered pre-release, at which point you kind of are allowed to sort of do whatever you want because it's considered still in the development stage. So I'm going to start off with the version 0.0.1, and I will leave it as a 0. Version until my package is ready for the public to use it. All right, we have a package JSON. That's great. We can actually go ahead and publish this now. It wouldn't really do anything useful. People would install it, and there wouldn't be anything that actually gets downloaded other than the package JSON itself. But that's great. The next thing, as we're writing our package in TypeScript, would be to install TypeScript. Now, I'm going to install this as a dev dependency rather than a normal dependency. Any normal dependencies will also be installed by any user that uses your library. So for things that are only required during the build time, during the build process, for people that are actually contributing and working on your project, should all be dev dependencies, so that people that are just trying to use your library don't inadvertently install that package as well. There is an image, let me see if I can find it here, that is worthwhile sharing. Actually, you know what? That's not going to work. I'll open it in Chrome. Some of you might be familiar with this when it's loaded. This is worth a delay. Just you wait. This. This is a pretty common situation. NPM has over 1 million packages. So unsurprisingly, some of those packages may not be very well architected. Some of them might require a lot of dependencies that require a lot of dependencies that require a lot of dependencies that may not be necessary. And a lot of these packages might also include a lot of assets that aren't really required for the operation of the package. So that's something I'm going to try and instill in you from today to have sort of good hygiene about. It's important to make sure your packages are as small as possible to minimize this, basically. So I'm going to go ahead and install TypeScript with npm. Great, the internet's working. And we have it ready. So at this point, if we do git status, there's a bunch of files there waiting for us. Is there anything here we might not want to check into the repository? I see some nodding heads. Yes, we don't want to check in node modules into the repository. That is, it adds unnecessary bloat, and we have plenty of information in the package and package lock file so that anyone that's actually working on this code base will install the right dependencies. So we're going to go ahead and create a git ignore file, which will tell Git lists of files we don't want to ever check in. Now I open that file, and I'll put in node modules like this. Now, Exactly how you structure your gitignore file is kind of up to you. I always like to preface most of my paths with slash, so that if there are any related things in subdirectories, they're not also excluded. You can always add them later. But now if I do git status here, you'll see that node modules has disappeared, but gitignore is now there, which is actually something we want to check into our repository so that everyone has the same files that they're excluding. So we can go ahead, add that, add all those informations, commit that with whatever commit message makes sense to you. All right, so we have a package.json, we have TypeScript, and we're ready to start using TypeScript. Now, you may have noticed that I didn't install the package TypeScript globally. I installed it locally to the package, which means that it's not available. All the binaries that come with TypeScript aren't available in the command line for me to use. I did that intentionally because there's quite often you might want different projects on your computer using different versions of TypeScript as you're like upgrading each of them, and it's good to. It's also generally good to not install too many things globally when that's unnecessary. The whole reason that Docker exists is pretty much because of that. So we want to be able to reference the TypeScript compiler from our command line. So there is the sort of correct way to do that, or the best way to do that would be to use the scripts property in a package.json. So you can write certain command line scripts within package.json that you can run later. Any of those scripts have the context of all the locally installed packages, so I can actually run the TypeScript compiler from there. So to show you what I mean, I'll write scripts here. I'll create a script that I'll call TSC, and all it's going to do is call TSC, which is the TypeScript compiler. Now, you'll notice that TSC isn't available as a command for me to run. But if I do npm run TSC, you see it actually runs the command. And I'm actually going to actually do something useful, print out the version. So we've got version 353, which is what matches in the package.json. So you'll notice I added a couple of extra dashes there. That's important so that when you run one of the npm scripts, it knows which arguments it should consume itself and which arguments it needs to pass on to the script. You'll quite often need to do this whenever your script needs to take arguments that start with a double dash, or might be something that npm is trying to interpret instead. So great, we got that. Now we can run TSC. We can run TSC's init setup to create an initial configuration for our TypeScript package. Great. And you'll notice there is now this tsconfig file that's appeared. We can have a look at this. So, I'm just going to move that down a bit. So it creates very usefully an initial configuration file with all of the standard configuration options that are available commented out and set to their defaults. It's very heavily documented, and this is extremely useful. Since they introduced this, I'm no longer Googling for what certain command line arguments or what certain configuration options are. It's all right here available. So now that we've done this, let's see. Now we have this available. We actually want to configure TypeScript so that we tell it where the code, where we're going to be, where our TypeScript code is going to live, where we want the JavaScript code to be output. So let's do that. The way that I'm going to structure this package is all of my TypeScript files are going to be in /source src, and I'm going to output all of my JavaScript files to /lib. This means there's a very nice separation between my source code and what I'm outputting from my source code, and can, with a single command line or a single command, just remove all of the compiled output. So I'm going to go ahead and set that up. So first one I want to set is, outdir, like that. The output directory is going to be lib. I'm going to set rootdir to be source, so that tells TypeScript. This is an optional thing to do, but I typically like to do it because if ever you potentially have many subdirectories within source, it might not work out where the root of your package is supposed to be. So I like to set this explicitly. And then I'm going to tell TypeScript to, by setting include here, the list of files I explicitly want it to compile, and that's everything in source, like this. So now that I've done this, if I try and run the compiler, I'm going to make this a bit bigger again. I'm going to unclose this. Try and run the compiler. Lots of error messages. What's it complaining about? No inputs were found. Well, that sounds about right because we actually haven't written any TypeScript yet, but things seem to be working. So I'm going to go ahead and commit these changes as well, saying that we've configured TypeScript how we like it. So git status, we've modified package, and we've got a tsconfig file. So git commit. Great. So we've got git ignore, package lock, package, readme, and tsconfig. So now that we've got everything configured, we can actually start writing our first TypeScript file. So I'm going to go ahead and do that. Okay, new file, or new folder, source. And inside of source, I'm going to create a new file I'm going to call index.ts. Now, I was trying to think of what would be a good little hello world kind of snippet to do. I don't know, potentially an inefficient version of Fibonacci? Sure, that's always a good thing to publish. For now, I'll just do a small hello world function. So I'll just do export function hello world. Have a parameter that's a string. And then print out. Oh, I'll use a template string there. Cool. So we've got our function. We've got our little library that's pretty simple. Now, if I try and compile it, let's see what happens. Great. It worked, it looks like. We can see now that there is a lib folder here. And if we look at this index.js file that's been produced, there's a bunch of boilerplate at the top. And it's got a function called hello world that you'll see has nicely converted my template string into just normal string concatenation. And it's exported that. So it's made that available, which is awesome. Cool. So if we look at the git status, we'll see that we have both the lib and source directories visible there. So nod your head if you think there's something we need to do before we commit or add all our files and commit. There's some nodding. Does anyone want to suggest what we might want to do? Ignore lib, yes. So let's go into git ignore. Let's add lib. Git status. Git ignore has been modified, and we have some source. Great. Let's add that. Commit it. And there we go. So something I'm not doing here is actually pushing any of this, all of my commits up to somewhere after I've committed, because I actually haven't set up a remote for this. Don't do that. Don't do what I'm doing. Make sure that you also set up a Git remote somewhere and constantly push all your changes upstream. The reason I'm not doing it is, of course, this is a demo. Let's see. So after I've done that, the final thing that we need to do to make our package kind of ready for publishing is to, in the package JSON, list where it needs to find our JavaScript files. So if we go, so we have, we're going to be, we're outputting our JavaScript to /lib, and index.js is the main sort of entry point to our package. So if we go to package here, what we're going to do is set main, and that's going to be lib index.js. So let's see. There was one other thing I wanted to do. So I mentioned a little while ago about you want to keep the size of your package as small as possible and still have it work. Right now, if I were to publish this current folder to NPM, it would include a lot more than I actually need. It would include namely, it would include the tsconfig file. It will include the TypeScript source code, which also isn't necessary for anyone that wants to use my module. They only care about the JavaScript. And I might also have other things in there. I might have documentation, which might include images, which might really bloat up my repository, all of which is completely useless and actually adds to the bloat when people just try and install the module. So what I'm going to do now, just keeping another time, is specify to NPM what files I actually care about including in the package and which files I don't. And there are two ways to go about doing this. You can use something similar to Git. You can use an npm ignore file, which will then exclude. I can tell it, OK, don't include source, don't include all these other things. But there's also another method that allows you in the package JSON to include specifically the files you want to package. So you got an option of either blacklisting or whitelisting files, and you can actually combine them together. I am going to highly recommend to everyone here that you opt for whitelisting files rather than blacklisting files, because otherwise you open yourself up to the chance of inadvertently publishing something that you didn't mean to because you created a file but you forgot to add it to the blacklist, that sort of thing. And then you just increase the size of your package. So to specify the whitelist of specific files I want to include, I'm just going to specify files here. And files will just be everything in lib. Now, let's see. Great. All right, let's commit those changes. Say prepare for publishing. All right. So we're pretty much ready to make our package go live. There's a nice little thing you can do called a dry run, which will effectively give you details and statistics about the package that you're about to make live. So here it says there are 2 files that are going to be uploaded. You have the lib index.json and the package JSON. And actually it includes the README as well, because we have a README there. But it's 0 bytes because I didn't save it. So why don't I save it? Do git status. Do a dry run again. Cool. And then I actually have some data in the README that's going to be bundled now. So this is a very good, useful sanity check that you can run before you actually do your publish each time. All right, so I think we're about ready. I'm going to get rid of the dry run argument, hit enter, see what happens. Aha. So namespaced packages by default the default behavior for them is to be private, so that you can, at the same time that namespaced packages were introduced in NPM, they also introduced the notion of private packages so that you could make them available only to your own teams. That is not what we want here. We want this package to be public. So instead, I can specify. Let's see if I can remember the command line for this. Public, maybe? Yes, all right. So it looks like it's publishing. OK, version 0.0.1 publish. Now if we go to, let's go to NPM. oops, npm.js.com. Great. TypeScript talks, version 0.1 with the README and everything available. So let's say we had another package. I'm going to create another folder. So this is going to be an example usage of it. So let's say we'll call this folder usage. We'll create and here we're not actually going to put anything interesting. And we're going to try installing and using the library. So let's do npm install. Did I say talk or talks? Let's see if that works. OK, it was talk. And we're also going to install TypeScript. Great, so our new package is going to be using our library, has got TypeScript and TypeScript talk installed. So we can now, if we look at the node modules here, we go into @Lanning TypeScript talk, we can see we've got lib with index.json, we've got package.json, we've got readme. But we haven't got any of the TypeScript source, we haven't got the TS config, we haven't got anything else that isn't actually useful to anyone using the node module. So now that we've done that, we can actually write some TypeScript code that uses it. So I'm going to be lazy and just not have a source directory here. Let's do import star as, oops. Great. And let's also initialize this in here, do scripts, tsc, npm run tsc, init. So that actually gets TypeScript working. And oh, what do you know? The import is not working. It says, could not find a declaration file for module Lanning TypeScript talk. And it would be right, because although our npm module is now usable for anyone that's just writing vanilla JavaScript, we didn't actually include the type definitions, and that's the whole point of this talk. So we can go ahead and go do that now. So if we go back to package here, we can tell the TypeScript compiler that we also, as well as exporting JS files, we want it to export TypeScript declaration files as well. So we go to the TS config, and we find the declaration here. And we want declaration to be true, as it's listed there. So you can save this. Now if we go back to the package, run the build, and if we look at lib here, we'll see now that as well as having an index.js file, it has index.d.ts file. And if we look in there, it includes the type declarations for the module that we want. Great, so now we can publish a new package that includes the type definitions so that anyone using TypeScript will automatically be able to use them. But before we do that, we also need to add it to the package JSON. So I'm also going to go to package.json here. Under main, I'm going to say types can be found in lib index.d.ts. So if I just do a quick git status here, we've modified package, we've modified TS config. We haven't modified the source. And even though we have a new file in lib, it's not detected because we're excluding everything in lib and generating it. So we can go ahead and add these changes. Say, and before we're able to publish again, we actually need to specify. We need to bump the version so that it actually gets republished. You'll see if I try and do an npm publish here. says you cannot publish over the previously published version. So let's do npm version patch. So this automatically bumps the version for us. And even if you look at the git log, creates a new commit for us and creates a tag for us that we can push up immediately up. So it's a really nice little command that does a lot of the housekeeping for managing versions. So you'll see that if I do git status, everything is clean. And now I can just run npm publish. I only needed to specify the access the first time I published it because the module didn't exist yet. Now I can just simply run npm publish. Great, I published version 2. And if I refresh npm here, you can see that a few seconds ago, I published version 2 there, or 0.2, because we're still in the dev stage. Great, now if I go back over to the usage here, I'll just navigate. I'll close this. Don't want that. Look at usage, look at index.ts. Now I'm in here, I can update the package so that I can take advantage of those types. If I do npm install at Sam Lanning at latest, it says upgrade to 0.02, and you can see immediately that the error in my editor has disappeared because the type definitions are now available. So in here, I can write tst.hello world, cool. And in here, what do I need to give it? A string. Save that. Let's run the compiler. We can see that index.js has been produced. Let's run that file. There we go. We have a TypeScript package with type definitions that we're able to immediately take advantage of in our TypeScript projects, and that anyone else using TypeScript can simply npm install your package and use all those types. So let's see. I still have 10 minutes left, so I'm going to add like one more little thing to the end just to show you what it looks like. So let's say I wasn't a fan of using underscores in names anymore, and I wanted to change my API. Let's go back to the source file here. Say, first thing I want to do is I'm going to change this to use camel case instead. I want it to be hello world. I also wanted like a little bit of documentation to be available to people. So like this function does stuff. And I also want to be a bit pedantic and make sure that people include both the first name and a last name. So let's do, the name has to have a first, which is string, and a last, which is string. And then I'll do name.first, name.last. OK, so we've updated our API. We've changed it a little bit. And it's important to know, I'm going to point this, we're not going to do this here because it's a demo and we're still in version 0.x.y. This is a backwards incompatible change, which means that if someone were to upgrade this, their existing usage would stop working. So typically at that point, you would upgrade the major version of your package. For new changes that you introduce that don't actually break backwards compatibility, you would generally upgrade the minor version, which is the middle thing. But because we're still in version 0, I'm just going to go ahead and bump the minor version, and be OK with breaking backwards compatibility. So now that we've done that, let's run the build. Node, oops. npm run. I'm in the wrong folder. npm run tsc. And then see what the git status is. Cool. I'll commit those changes. And also, if you look at the declaration file that's now been produced here, you'll see that as well as producing some type definitions for the new parameters, it's actually also included the documentation there, which means that I'm going to be able to see that in my IDE as a user of this library that I'll show you in a second. So now I've made this change, I'm going to quickly do npm version minor, and then npm publish. we'll go back to my usage here. Open this file. And we're going to upgrade the version of the library. So do npm install the latest version. Oh, look, a nice big red error message on the hello world because I changed the name of it. So I'm just going to go ahead and hover that. Is there any quick fixes? No, it's not. It's not suggesting anything. So I'm just going to go ahead and change it to hello world. And oh, there's a problem with my parameter because it requires first and last name. So I'm going to do first that, last. And then something you'll notice is like autocomplete is very, very handy and really helps speed up development when you've got TypeScript working. Close this, save that, compile it, and run it. Great. Yeah, oh, and also I hover over hello world here, and I got the documentation. This function does stuff. Cool. That's about it. Thanks. So I have 5 minutes to take any questions from anyone. Great. Oh, one last thing. I have stickers. If anyone wants any TypeScript stickers, come see me. If you have any questions about TypeScript generally as well, come say hi. Thank you.